Here we already created a new project with EAE called Injection Molding Machine version 01. Before we start developing, we will have to create some utility objects and functions. Since we will create a digital twin simulation, we will need a kind of random number generator. This we will create as first using pseudo-randomness. We will do this by creating a function. We have our input called seed and our output, the random number, called number. We will use some numbers. I don't know, 1301 is a prime number. And I will mod it with 99.9 and divide with 100. So the end result is something between 0 and 0.999. Now let's quickly test it inside a basic block. If we don't need the init part, then I like to delete it immediately. The basic block will have an output called R&D num. Now let's test it, and it doesn't work. Oh, I forgot to initialize it. Otherwise it is 0 and then it can't work. Now let's test again, and here we see a creating of random numbers between 0 and 1 inside a real variable. We don't need the basic block since it was used only for a quick test. Now we will create an initialization block, which we will use very often. It will be a composite, but I will need for that block an adapter called init. In our case, all adapters will start with I underscore. This adapter has only one output event called init. Now we create the composite block init underscore fb. We will delete everything and put our I underscore init adapter here. Now it looks better. Inside that block, we have to call the PLC start. This way we will produce an event each time the PLC restarts. Why can't I find this block? Oh yeah, we created a project without any additional libraries. I promised you to make a project from scratch. When you start, you should create a project with libraries already included. It's easier this way. So because I started the project from scratch, I have to reference the corresponding library. Where was it again? I think it's the app-based library. Let's add this library. There is the PLC start block. Let's add the inputs since we don't want to call the PLC start with priority and delay equals 0. Now we will create a periodic simulation call for our digital twin. I will call this composite SimCyclic. Inside this composite, we will have a Symlink destination block. We will here read the value of a variable called simulation of type bool. If this Boolean variable becomes true, we will start a cyclic event generator. If it becomes false, we will stop this cyclic event generator. The period for generating events is adjustable through the variable cyclic time. We can comment our code by using frames. I usually do that at the end, but here is how to do that. We add a frame and adjust its size. Double-click the frame and enter some comment under the text entry. Here we want to get the simulation value. And here we are generating a cyclic event if the simulation value equals true. Now let's create our first cat called console. Here we will have an output variable simulation of type bool. Let's enter the corresponding event CNF. CNF stands for confirmation. Inside this cat, we will write the variable called simulation of type bool. That init output must be actually here. Let's connect everything. Update the root. Now we will place the button for changing the value of our Boolean variable simulation. We will use an on-off button for that purpose. Let's place a corresponding label called simulation. Now we can place this cut inside our system so that it can be mapped to our hardware resource in order to be executed. I will call this instance console, like the object name. If the background is gray, then we are inside the instance and not inside the object, and here we can't edit anything. Let's go to the object console because I forgot to delete something. Now we save it, and I want each instance of this object to initialize automatically and not through an input event. Let's delete the init input event. I advise you to use a priority of 50 or higher and a delay time of several hundred milliseconds. Save it by pressing Ctrl S. I don't want these output events since I will not use them. The Symlink source object will trigger the corresponding Symlink destination object inside the composite sim_cyclic automatically. That's why I don't need these output events. I also don't need the simulation value as an output. Now it is better. Now let's map it to our resource echo_rt_resource0. This is an automatically generated resource after you create a project. Now we will start a PLC simulation, but first we must compile the project. Okay, we have an error. Let's see. Yes, we are not in a local test mode. Now compile again. Great. Before we deploy, let's create a local HMI so that we can press the simulation button of the instance console. I will create a local HMI with the resolution 1280 with 800, and I will also create a canvas inside this HMI called main. Here I will place our instance console, which is already mapped. If you forgot to map a cat, you will not see it under instances. It is not yet compiled. Let's clean and rebuild the HMI. Now we can place the instance inside the canvas main. Let's deploy and start the PLC. We will also start the HMI. Our instance is purple, which means it is not mapped. Did I map it correctly? Still purple. Let me restart the HMI. Okay, now it is not purple. But it is grayed out, which means it is not initialized. Why is it not initialized? let's go into our instance and watch the IDIS instance block. The init event is still 0. Why didn't the PLC start created this event? Let's watch this block too. I think I forgot something. Oh yeah, I have to call inside the hardware once the debug full init block. This is necessary. Let's switch to device and add this block inside our resource EcoRT. Now we deploy again, but first we must clean the old deploy, compile, deploy, and start. Let's see if the init event has been created this time. Yes, it is. Now let's switch the button and see if the value is changing inside the PLC logic. All good for now. Now let's test the sim cyclic block. We will place it inside the system application just for a quick test. The instance name is FB1 and we will not change it since it will be deleted after the test. Let's deploy this. But first we need to clean. You know what? Let's do a small break here and change the hardware behavior. I am too lazy to always clean it manually. I want the cleaning to be executed automatically after deploy or at the deploy. We will enter the logical device tab under System. Under Deploy Service, we will turn on the Clean Before Deploy option. We will also automatically run the PLC after the deploy. Now let's deploy this hardware configuration to the device. But first we must clean it. Now deploy new device configuration. Now I will deploy it and the PLC should enter the run mode immediately. It's not happening. Why is it not happening? Yes, we have to set this value, auto start after deploy, to true. Run the PLC inside the boot record. We'll put the PLC in run mode, but only after a power restart and not after a new deploy. But we will also leave this option to true. Let's clean again and deploy device configuration. Log in and deploy again. And now we are automatically entering the running state. Very good. Now let's get back to our sim cyclic block. Let's see if the event is being generated after the simulation is turned on. No, it is not working yet. I don't see the value changing inside the Simlink destination instance. Why not? Let's go to our console, since the simulation value is written here. The IDIS block looks good. I think we need to trigger the request on the Simlink source instance. Yes. Now let's go back inside the SimCyclic instance and see if the Simlink destination has changed to true. Yes, it did. Very good. Let's change our Cyclic object so that it works properly. Let's change our console object so that it works properly. We connect the request event with the confirmation event of the IDs block. We deploy and test again. And now we have a periodic event generation if the simulation is activated. If I turn the simulation off, the event generation is stopped. Very good.